Babbage was born on December 26, 1791 in London, United Kingdom, to affluent parents and was educated at Cambridge University. Recognized at a young age for his scientific talent, he was elected to the prestigious Lucasian Chair of Mathematics at Cambridge in 1823. He devoted much of his time to study logarithms and building a device that would use machine power to accurately calculate and print out functions.
Charles Babbage's statements in the book Passages from the Life of a Philosopher, 1864. In his childhood, Babbage always wanted to know and investigate more about the causes of these little things and events that amazed the childish mind. After a time, he started on of his most important investigations that were based on the laws of thought that help the human mind to pass from received knowledge to an unknown knowledge for our race. The search for truth was always his proposal. Sometimes he moved away from his inquiries because of the conclusion they could drive. His parents, Benjamin Babbage and Betsy Plumber Tape, followed the religion of their country. He was raised in the Protestant form of the Christian faith. Being passionately fond of algebra, he made studies of mathematical work and elaborated the sketch of society, to be instituted to translate the small work of the Lacroix on differential and comprehensive Lacroix.
Difference engine. Given sharp background in mechanical engineering, he tried to create a device that would solve tables automatically and accurately, thus saving engineers time and money. In 1819, Babbage began building a small model of the mechanical calculator he had devised. It took him 3 years to complete it, and in 1822 he had the finished model, now known as Difference Engine 0. This machine was capable of calculating and printing tables of the mathematical type, all through the user input from the hand crank.
Analytical engine. This design was more similar to a general-purpose computer that could do arithmetic logic, have conditional formulas and loops, as well as a form of mechanical memory. All of the programming for the mechanical computer was designed to be done using punch cards. Era Lovelace, a British mathematician at the time, worked on developing instructions for Babbage's machine, completing the project soon after. Railroad invention. In 1838, Babbage invented a device that sits on the front of rail engines called the pilot, or more colloquially, the cow-catcher. This was a metal frame that fit the front of trains to clear the tracks of obstacles. Charles Babbage's contributions to humanity were a few of the most diverse, covering disciplines ranging from mechanical engineering, computer science to management, economics, philosophy, and what we would already define today as managerial thinking. Some of these are calculus and functions.
Economic management principle. He analyzed the cost of the process. His ideas belong to the systematic approach. He requires the recognition of the interests of the worker and the factory owner, giving rise to the payment of incentives and profit sharing. Principles of taxation. In a pamphlet printed in 1848, he published his view of taxation, especially concerning an income tax. The principal support there was entertained and examined by the French Minister of Finance, Passy. The nine Brigadier Tracy. Charles presents the thesis that God had the omnipotence and foresee to create as divine lawgiver. In this book, he was concerned with relating interpretations between science and religion. In fact, he insisted that there is no fatal collision between the work of a sculptor and the fact of nature.
He worked until his death on his analytic engine, of which he was only able to construct a framing. However, his notes amazingly describe almost all the features incorporated today in the modern electronic computer. Unfortunately, technical limitations prevent the realization of the machines. After a century of the advent of electronic technology, Babbage's dream became a reality. The union of steam engine, clockwork mechanisms, and water and wheel mines was not enough for Babbage's ingenious methods. In 1832, he wrote a treatise on the economies of machines and manufactures, in which he designed some principles that, according to his concept, should be applied to the organization to achieve greater productivity. Through the division of labor, he reduced idle times, made operations more efficient, and generated results with the reduction of material waste. His principles were considered the most advanced for several decades. Besides, he developed some of the first ideas on time and motion studies.